All right, let's try and understand this graph. This graph is of x over m on y-axis and pressure on x-axis. What is x? X is mass of gas adsorbed. Mass of gas adsorbed. What is m? M is mass of adsorbent. Mass of adsorbent. All right. Now, one thing keep in mind. Now, for a particular system, if I am carrying out a reaction, all right, I am carrying out a process. Now, I am carrying out a process with, suppose, some solid substance. Mass of that solid substance or mass of adsorbent remains constant. So basically, when I say x over m, that itself means x, which is the variable, whereas m is constant for a particular system. Okay, if I'm changing the system, obviously the mass would change, but then for that particular system, again the mass would remain the same. All right, mass of adsorbent would remain the same. So keep this in mind always whenever we are carrying out any process. All right, okay. Then what is K? K is temperature in Kelvin. Now let's pick up one isotherm. Isotherm, I presume you know, when a reaction is carried out at constant temperature, we call it as isotherm. Now this has been carried out at a particular temperature. This has been carried out at a lower temperature. Now we know K3, K2, K1. K3 is highest temperature, K2 is lower, and K1 is the lowest temperature, low temperature. All right. So this is lowest temperature. This is the highest temperature. That's what I mentioned over here. K3 greater than K2 greater than K1, where K I represent it as temperature since Kelvin, so I chose K as my letter. All right. So at what we find is that at any temperature, adsorption increases with pressure. So see, what we are finding is, now let's pick up this K3 isotherm. Let's pick up this K3 isotherm. Now in case of K3, where the temperature is fixed, all right, at that fixed temperature, as we keep on increasing the pressure, we find that the X keeps on increasing. All right, so adsorption keeps on increasing with pressure. Now I already told you that in case of adsorption, it may form one layer on the surface, may form yet another layer. So adsorption keeps on increasing, or the value of X keeps on increasing. But then there's a limit. All right. After that, it remains constant. So no matter whatever temperature you try with, same is the observation. All right. Now yet another observation with temperature. What we find is, now see, if you check out over here, go on y-axis. Y-axis deals with what? Y-axis deals with X, that is material adsorbed on the surface. When the temperature is lowest, adsorption is maximum. When temperature is highest, adsorption is minimum. So what can we conclude? Low temperature and high pressure is what is required for adsorption to be high. All right. So, and this is what? High temperature, very high temperature, and maybe same pressure. Compare it with same pressure, right? Same pressure, high pressure we are talking about. Why am I saying high pressure? Because see, if we go here, the pressure is low. All right. So I'm picking up this. So this is a high pressure, low temperature, whereas this is high pressure and high temperature. So the material adsorbed is very low. These are the observations that we observe. So first one, at any temperature, adsorption increases with P. So at any temperature, whether it be K1, K2, K3, adsorption increases as the pressure increases. All right. But at constant pressure, so this is the constant pressure, adsorption is inversely proportional to temperature. If temperature is low, adsorption is high. If temperature is high, adsorption is low. All right. So this is the conclusion that we get from this graph. All right.